morning students. Now we are going to discussing some different problems from our material. So module 1 class work first question. A student was asked to prove a statement by induction. He proved first one P of 5 is true and second one truth of P of n implies truth of P of n plus 1 comma n belongs to n. On the basis of this he could conclude that P of n is true for no n belongs to n, for all n is greater than or equal to 5 n belongs to n, for all n belongs to n, for all n is greater than or equal to 1 n belongs to n. So which option is correct? So he proved P of 5 is true and P of n is true implies that means truth of P of n means he has assumption is P of n and he proved P of n plus 1. Okay, in general we are going to prove P of 1 is true and the truth of P of k or P of n or P of m whatever may be, okay, implies truth of P of n plus 1. Okay, so this means P of 1 is true and truth of P of n implies truth of P of n plus 1 means that is true for all n belongs to n. N belongs to n means natural numbers starting from 1. Okay, but here we proved starting from 5. So in this case it is possible only for all n is greater than or equal to 5 n belongs to n only. So from 5 it is we can say. Okay, so from 1 it is not correct. So these three options not correct. The second option is correct for this question. Next question. If P of n be statement n into n plus 1 is an integer, then which of the following is even? So even means even number. So P of 2 is even, P of 3 is even, P of 4 are none. P of 2 if you take, that means n is equal to you take 2 into 2 plus 1. 2 3s are 6 plus 1, 7 odd number. P of 3, 3 into 3 plus 1, 3 4s are 12 plus 1 odd number. And P of 4, 4 into 5, 4 5s are 20 plus 1 odd number. So none of 1 is even number here. Okay, second option, second question, fourth option. First question, second option. So now go to third question. For n is greater than 1, n is even implies digit in the units place of 2 power 2n plus 1. Okay, so after greater than 1, you should consider only even numbers. So if you substitute even numbers in this one, what is the unit digit in this one? So first you take n is greater than 1, even number is n is equal to 2, first even number. That means 2 power 2 into 2 plus 1, that is 2 power 4 plus 1. So 2 power 4 plus 1 means 16 plus 1, that is equal to 17. Here unit digit is 7. If you want to take n is equal to 4 also for verification, better understanding. 2 power 2 into 4 plus 1, that is 2 power 8 plus 1. 2 power 8 is nothing but 256 plus 1, that is 257. So in both cases we got only 7 is the units place. Okay, so if you go for n is equal to 6, n is equal to 8 also, you get units place 7 only. So answer is 7. So second option. Next, fifth question. N factorial whole square is greater than n power n is true for. N factorial means already we know. Factorial means product of first n natural numbers. For suppose 3 factorial is equal to 3 into 2 into 1. 2 factorial is equal to 2 into 1. So 1 factorial is equal to 1 only. So 7 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. Like that we have to write. Remember. Okay. So now n factorial whole square is greater than n power n is true for all n belongs to n. For all n is greater than 1. N is greater than 2. And for all n belongs to z. Z means positive numbers and negative numbers. Okay. So first you take for n is equal to 1. Actually negative numbers, for negative numbers n factorial is not possible, so we can't go with the fourth option. Okay, so this is possible only for natural numbers factorial. So if you take negative numbers, we cannot consider this one because it is not defined, so z is not possible. So directly you go for natural numbers starting from 1. So n is equal to 1, you take 1 factorial. 1 factorial is equal to 1. 1 square u, that is equal to 1. N power n, second condition n power n. N power n is 1 power 1, that is equal to 1. Is 1 is greater than 1? No. So n1 is equal to 1. So n factorial whole square is doesn't greater than n power n for n is equal to 1. Next you take n is equal to 2. 2 factorial whole square. 2 factorial whole square is equal to 2 into 1 whole square. Already I told you. So 2 into 1 whole square is equal to 4. 2 square is equal to 4. Here also 4 is not greater than 4. 4 is equal to 4. So n factorial whole square is doesn't greater than n power n for n is equal to 2. Next n is equal to 3. So 3 factorial whole square is equal to 3 into 2 into 1, that is equal to 6 square, that is 36. So next 3 cube. 3 cube is equal to 27. Yes. For n is equal to 3, 36 is greater than 27. So n factorial whole square is greater than n power n for n is equal to 3. Similarly, if you go for n is equal to 4 for better understanding, 4 factorial whole square is equal to 4 into 3 into 2 into 1. So that is equal to 4 3s are 12, 12 2s are 24, 24 whole square is equal to 576. Next 4 power 4. 4 power 4 is nothing but for n is equal to 4, substitute in right side. And 4 power 4, that is equal to 256. So here also 576 is greater than 256 for n is equal to 4. So n factorial whole square is greater than n power n for n is equal to 4. That means up to 2 it is not possible, but after greater than 2, after greater than 2 means from n is equal to 3, you get the given inequality. So what is the answer? Third option. For all n is greater than 2. Greater than 2 means after 2 what is the natural number? 3. From 3 it is possible. So third option. Next question. Module 2 classwork. All these are different problems from our material. So remaining problems what I am not discussing. Remaining problems we can go with verification. So next question. If ak is equal to 1 by k into k plus 1 for k is equal to 1, 2, 3 and so on n, then sigma k is equal to 1 to n ak whole square is equal to is asking. Here ak means kth term or nth term or tth term, whatever may be they may give. If they in the place of k, if they given an is equal to 1 by n into n plus 1, then he will ask sigma n is equal to 1 to n only they will give. No problem. Okay, so that means here sigma means expansion, summation. Okay, so first you substitute a0, sorry, here starting from 1, a1 whole square plus a2, that means whole square, sigma whole square means a1 plus a2 plus a3 plus a4 plus up to plus an whole square is asking. So they given ak. Okay, so this is a kth term. First, whenever they given something 1 by k into k plus 1 product of two consecutive factors. So this by using this denominator we should write numerator by subtracting these two, and we have to balancing. If these are not consecutive, for suppose here k and k plus 2 they given, we have to balance it. So generally if they given k into k plus 1, so if you subtract k from k plus 1 you get 1. Okay, so we can balance it that is as here ak is equal to 1 by k into k plus 1. So this numerator you can write in terms of denominator is k plus 1 minus k. This is the one of the procedure whenever they are given like this question. Okay, so now you split it. So k plus 1 minus k, split it, k plus 1 by k into k plus 1 minus k by k into k plus 1, that is equal to k plus 1 by k into k plus 1 minus k by k into k plus 1. So here k plus 1 cancel, 1 by k minus k cancel, 1 by k plus 1. So this is ak. Now what you want? Sigma k is equal to 1 to n ak whole square you want. Okay, ak whole square means first sigma means summation. So summation means sigma k is equal to 1 to n ak means what it is? Ak means just I didn't write here, so I am expansion here. Sigma ak whole square is equal to a1 plus a2 plus a3 plus and so on plus an whole square. He is asking about this one. So this one is nothing but a1 means what? In that case, substitute 1 here. That is 1 by 1 minus 1 by 1 plus 1. That is 1 by 1 minus 1 by 2. A2 means what? 1 by 2 minus 1 by 2 plus 1. That is, I am writing like this for our convenience. Plus 1 by 2 minus 1 by 3. Next, A3 means 1 by 3 minus 1 by 4. Plus and so on. An means what? 1 by n minus 1 by n plus 1. Whole square, same. So if you observe this one, 1 by 1 minus 1 by 2 plus 1 by 2. So these two will get cancelled. Minus 1 by 3 plus 1 by 3. These two will get cancelled. Minus 1 by 4 plus 1 by 4 will cancel. So that means these two and these two also will get. That means 1 by n before term and this 1 by n will get cancelled. So for this one there is no other number, for 1 by 1 there is no preceding number. So the remaining, after cancellation, the remaining terms will be 1 by 1, that is 1 minus 1 by n plus 1 whole square. So if we take LCM, so n plus 1 minus 1 by n plus 1 whole square. So 1 get cancelled, that is n square by n plus 1 whole square. So this is the answer for this question. So n square by n plus 1 whole square. This problem you can go with verification also. See here, ak is equal to 1 by k into k plus 1, sigma k is equal to 1 to n ak whole square is asking. If you take for suppose if you take n is equal to 1, okay, for n is equal to 1, so what is asking? Sigma k is equal to 1 to n ak whole square. That means what? Sigma k, only one term you have to consider. Okay, for n is equal to 1 means only one term, that is a1 square you want. Okay, a1 square. So a1 square is nothing but 1 by 1 into 1 plus 1 whole square, because ak is equal to 1 by k into k plus 1. So a1 means 1 by 1 plus 1 whole square, this one you want. Okay, so this is nothing but 1 by 2 square means 4, 1 by 4. If you go with options, first option, option 1, what it is? N by n plus 1, that is nothing but n means 1, 1 plus 1, that is 1 by 2, not correct. Second option, n square by n plus 1 whole square, that is equal to, n square means 1 square, 1 square is equal to 1, n plus 1 whole square is equal to that is 1 plus 1 2 square, that is equal to 4. So these two are equal, but we have to still verify third option. So third option is what? N power 4, 1 by 1 plus 1 whole power 4. See here, third option, n power 4 by n plus 1 whole power 4. So whole power 4 means 1 by 2 power 4, that is equal to 1 by 16, not correct answer. Fourth option, so n power 6, that means n power 6 by n plus 1 whole power 6, fourth option. That means n power 6 means 1 power 6, 1 by 1 plus 1 whole power 6, that is 1 by 2 power 6. It is also not equal to 1 by 4. So this is also not correct answer. So what is the option? Second option. Verification also we can do. But sometimes if you remember the procedure also, how to do like these problems, then we can get it easily answer. Okay, both ways we can learn for this question. Okay.